Okay, so in this tutorial, we're going to be going over a bunch of the grouping functions. And the first function we're going to be going over is .ag. You can use .ag when you want pivot table style calculated column or statistic. So basically this is what the output looks like. We have one row per group, and then we can have one or more summary statistics per group. So before I get into the code, I just want to quickly go over the data we have here. I have the first 6 lines and the headers visible, of course, but there's actually more to it if you expand this little plus icon. We're working with about 80 rows of basically just a product database. Very simple, should be good for our demonstration here. So the first thing we're going to do, like we do with most Python and Excel projects, is type equals py tab, and that'll get us into the Python code editor. And then we're going to go ahead and highlight our data, including the column headers. And then we just want to make sure that this headers equals true argument is automatically put in there. And then we assign a variable name to this. And what this is going to do is convert the Excel data into a pandas data frame so that Python can understand it. And then we reference the data frame with this variable when we want to use it in the Python code. But I have already done that right here. So we are going to be referring to the data as original data. And in the next step, we're just going to create what's called a group object in Python. And a group object is created by using the .groupby function, and which is available when you have a data frame. So we have our original data frame. We're going to put .groupby, and then for the arguments, we're going to put product, category, and brand, and that's in a list form. So remember, lists go in square brackets. And what this is going to do is create basically several kind of lookup tables almost that's going to help Python more efficiently create our final data frame down here. The groupby function only creates a group object, and the group object consists of more than one table. So if you're curious and want to know more about what the group object kind of looks like under the hood and what those multiple tables represent, you can go to this group object tab, and I've kind of outlined what those tables look like. But it's not entirely necessary that you understand what's going on under the hood, as long as you just understand the concept that a group object is not a single table, and that's why Excel can't display it. So don't worry if you look at this tab and you don't understand what's going on. If you were to try and spill the values of the group object like this into Excel, you'll get an error because a group object is not really a single table that Excel can display. And you'll know that you entered the group object code correctly if you see this data frame group by in the Python code cell that you entered the group by function in. And then in the next step, we are going to use that group object to generate our summary table as a data frame. So the code to do that is you're going to set a variable name, and then you're going to set that equal to the group object that you created in the previous step. And then we're going to use that .ag function. And as the parameters for that function, the first one is going to be explicitly the column header for the calculated column that you want to make. And notably, this is not in quotes and it can't have spaces. So it's just going to be exactly how you write it right here. So there's no quotes. And then we put an equal sign, and then we have these two parameters here, which basically specify the statistic type, which is the second parameter, and then which column is involved in calculating that statistic. So we are doing the count of the items for each group in this case. And then of course we close the parenthesis, and that will give us this table here, which I've just referenced to this cell here. So if you want to kind of move the output of a Python cell, you can just create a reference with the Excel function. So you go equals py tab, and then you just click on the cell that has the output you want. And then for this last step here, I'm just basically doing the same thing I did in the previous step. So I have our column header, type of statistic we want, and the column to calculate that statistic with, and put a comma, and then use the same syntax to specify the next calculated column. And you can do this with as many columns as you want. You just put a comma in between the code for the calculated column. So the next function I want to go over is called .transform, and .transform is similar to .ag in that it calculates group level statistics, but the key differentiator is the way that it outputs those statistics. So while .ag does one line per group, .transform will do one line per line of the original data frame. And this can be particularly useful when you want to calculate the percentage of a group total. For example, if I am grouping by product category and brand, these first two lines are going to be in the same group, but there's a whole bunch of other group members down later in the data set. So we use .transform to calculate the sum of revenue in all items in the group, which is 2118.9. And then we can compare that to just the revenue for any given line to calculate the percent of total revenue. So as you may have noticed, the data that we are using for this example is similar but not identical to the .ag data. Instead of wholesale cost and retail price, I have just a revenue column, and code starts the same way as ag. The first step is to get all of your Excel data right here into an Excel function with headers equals true, and that's going to convert your Excel data to a pandas data frame so Python can understand it, and we are going to reference that data frame with the variable name original data. And then next we are going to apply the groupby function to the original data frame variable, and again we are going to pass in a list to specify which columns to group by, and we are going to group by product category and brand. Don't forget to enclose in square brackets and use quotes around the column header names. And then after we create our group object, we go ahead and actually use the .transform function. Its syntax is quite different from .ag. What we do is we reference the group object, and then we reference one of the column headers from the data frame that we made the group object with. So in this case, we are going to reference the revenue column and then enclose that with square brackets immediately after you reference the group data variable, and be sure to put the column header name in quotes, and then we put .transform and pass in the name of the statistic that you want for this column right here at the group level. So we're using .sum in this case. This could be count, min, max, a whole bunch of other things. And I will be posting a link to this file on my website, which I'll leave a link in the description for, so you can take a closer look at some of the built-in functions I've listed for you right here. You can even use custom functions if you want, but this is just an intro video, so I won't get into them. Anyways, so the .transform function generates a series, which is a pandas object. It's pretty much the same thing as a data frame when it has an index here, just like a data frame does, but it only has one column. And then one important thing to note about the series that gets generated with .transform is that the row labels, aka the index, those are going to line up with the same index number as the original data frame right here. So if we look at the original data frame's row number 3, so right here, this line is going to match up with the series value right here. So because the row labels, aka indexes, align with the original data frame and our series objects, we can easily create a new column in the original data frame called group revenue, and then we can just set that equal to the series group sum column that we made in this previous step. I think I forgot to mention that I named this group sum column. So just to jog your memory, when you want to make a new column in pandas or in a data frame of any kind, you just reference the data frame name, and then immediately after, so no space, you put a square bracket and then in quotes the name of the new column you want to create, and then an equal sign, and then some sort of code that will help Python populate the values in that column. So in this case, it's the series object that we just made. And then the last step of this demo is basically calculating what percent of the group total each line is in the data frame. So again, we create a new column in the original data frame called percent to group total, and then we have our equal sign, and we tell Python to populate the values row by row by taking the revenue column in the original data frame and dividing it by the group revenue column that we made in the previous step. And then of course that percent to group total column is right here, and I'm going to go ahead and format those values using Excel because it's one click and it would be a little more involved if I was to use Python. Same for these. I'll just format those as currency, and there's our summary table. Okay, so the next function we're going to be going over is .apply, and if you think of .ag and .transform as being limited, .ag by the fact that you can only have one row per group, and .transform being limited by the fact that you can only have one row per row in the original data frame, the .apply function is basically going to allow us to kind of fill in those gaps. And actually .apply can do anything that .ag or .transform can do. The reason we use .apply only when we need to is because .ag and .transform are much faster processing wise. So if you're working with a large data set, like 10,000 rows or more, you're probably going to want to try and use ag or transform when you can. So in this example, we're going to be using a similar data set to the one we use for .transform, where we have revenue by item with brand, product category, and product type. And what we're going to be doing is using .apply in conjunction with another function called nlargest to return the top 3 revenue generating products from each group that we make. So the first thing we're going to need to do is the same exact thing we had to do with .ag and .transform, and that is to load the Excel data using the Excel function to load our Excel data with headers and ensuring that headers equals true gets populated when you do that, and then assigning that data frame to a variable called original data. And then in the next step, we're going to go ahead and apply the groupby function to that original data variable we made in the previous step. And we are going to be grouping by product category and brand. Don't forget to put those column headers in quotes and enclose all the columns you list as a list, so use square brackets. And then we're going to be assigning that group object to the variable name grouped data. And then the third step is basically a preparation for the fourth step down here, which I'll get to why that's an error in a second, because the .apply function takes the name of a custom function as one of its possible arguments. So basically what's going to happen when we use .apply and then we pass this custom function name into it is it's going to apply this function to each group in the grouped data object and then store the value. And then after it goes through each group, it's going to glue all the values together vertically into one single data frame. So one quick thing to remember if you are at all familiar with working with data frames in pandas in Python is that any function that works with a data frame will also work with groups within a group object when you use it with .apply. And the function nlargest here is no exception to that rule, so it works just the same way as it would with a data frame, except in this case we are going to be using with a group, thus the variable name of this custom function is a group. So what nlargest does, if you're not familiar with it, it returns the top n number of values, where this number right here is n, so it's going to be the top 3 values based on whatever column you specify here, so revenue. So it's going to be the top 3 revenue generating products for each group when we use it with .apply. And then in this next step here, we're actually using the .apply function and passing that custom function we just made as the argument. And notably, you do not include parentheses when you reference the custom function, so just reference it like it's a variable. And then you'll see that we actually have an error here, which is very confusing to say the least, because it's actually just a bug. The code within this cell actually is working, and we know that because we have this variable right here, top 3 revenue products, and then we use that same variable in the next cell and apply this reset index drop equals true to it, and it gives us the output we want. So probably has something to do with indexing, maybe a multi-indexing issue, which don't concern yourself about that at this point if you're just beginning, but hopefully they will get this issue fixed soon. Luckily, it doesn't prevent this demo or any other demos from working. Anyways, sorry for that sidebar. So this should just say data frame is the moral of that story. And then in this last cell here, we are just cleaning up the values with that reset index function, setting the drop parameter equal to true. So that's just gonna reset the index and make it so when we reference the cell with the Excel function and then spill the Excel values, it comes out nice and clean without an index column on the left here. Next example, I'm going to show you how to filter out entire groups from the final data set. Specifically, we are going to be filtering out groups that contain more than 3 items in them. So we are just left with items in groups that have less than or equal to 3 items. And the data for this demo is very similar to the demo data in .ag. So we have product category, brand, item, price, and wholesale cost. And this time we're just going to be grouping the data by brand. So the first step is going to be the same as our first steps for all the other examples. We're just going to use the Excel function to create a data frame from actual Excel cells. And we're just going to make sure that headers equals true. And then we are going to assign this data frame to a variable named original data. And for the next step, we are going to apply the groupby function to the original data frame to create our group object, just like we have done in previous examples. Don't forget to enclose the column headers from the original data frame in square brackets, so it's a list, and enclose the name of the column header in quotes. So before I get into step 3, I think it'll make more sense if I jump to step 4 and show you how step 3 is involved. So step 4, we're taking our group object called grouped data in this case, and we're applying the .filter function to it. And because .filter is attached to the group object, we need to make sure this custom function is designed to work with data formatted as a group. So the grouping function or the group compatible function we are using in our custom function is going to be the len function, and len stands for length, and it of course takes a group from a group object as its argument, and what it returns is the number of rows within a group. So if that number of rows is less than or equal to 3, then we're going to get a true, and all rows from whatever group we're evaluating will stay in the data frame for the final output. And if it's false, all the rows for those groups will get dropped. So here is what step 4 looks like as its output. It's almost what we want, except that we want to get rid of this index column. Everything else is looking good though. So in the last step here, we're just going to reference the variable from step 4 and add a reset index function to it with the parameter drop equals true. And that will give us this nice clean data set. And of course, I format using Excel because I can just do it in one click as opposed to typing out the code in Python. Okay, so before I jump into the example of using .shift with a group object, I just want to quickly go over what .shift is just with a regular data frame. And that way, when we use it with a group object, it'll be a little easier to digest and understand what's going on. So if we start out with just our original data frame, something that looks like this. Remember, all data frames have to have an index. It may or may not be in order, but every row in a data frame always has an index or like a row label. So what .shift does is it's going to shift all the data up or down the specified number of rows. So if you do a positive number, it will shift down whatever that number is, many rows. So if you did like shift 3 as the argument, it would shift down 3 rows like this. And then if you shifted -3, it would go up 1, 2, 3 rows like this, but it would preserve the column headers. So just as a quick example here, in this situation, the code for this table might be the data frame variable name that you chose. So you take that variable name and then you add .shift to it with a 1 in the parameter, and the positive 1 means shift down. You'll see that with positive 1, this row gets moved to the second row, this row gets moved to the third row, this third row gets moved to the fourth row, and so on, all the way down to the bottom of the data. And then of course, you'll see this kind of error message here in the very first row when you're shifting down, because there's no data to pull into the first row, so you'll just get these numbered errors. That's totally normal. And then for the very last row, since there's no row label for it, no more row labels for it to like get assigned to at the bottom, we are gonna lose the very last line. So that's when you're shifting down. So it's kind of not intuitive, because positive, you would think up, positive, but positive means shift down. And then if you put a -1 in, or a negative any number in the shift function, it's going to shift the data up that many rows that you specified in the argument. So in this case, we specified a -1, so all the data is going to get shifted up 1 row. And when we do that, remember the index stays put. So when we do that, kind of nothing gets pulled into this row label number 1 right here at the bottom. So that's why we get the number errors, which is fine again. And then at the top, there is no row label to assign to this very first row in the data set. So it's not going to be included in the resulting data frame. So when we use .shift with a group object, it behaves a little bit differently, but still similar in many ways. Basically, in a nutshell, it's going to treat each group as if it's its own data frame. So if we have a group object, say, that looks something like this, where it's grouped by store location, so the data in theory looks like this, where we have kind of 5 different tables. If we were to shift the data up 1 row, so supply a -1 to a .shift function that's attached to the group object, what it's going to do is still shift everything, like, relative to the index still stays the same. So we're shifting up 1 row, but instead of having this row bleed into the next group, it's just gonna look like this, and this row is going to be a number error. So basically, long story short, groups do not shift into each other when you're using .shift with a group object. Okay, so on to the final example in this tutorial series. If you've made it this far, congratulations, and thank you for staying tuned. So we're going to be using the .shift function with a group object in this demo. Our data set has sales volume per day per store location. And basically, we are going to end up with a table that looks like this. So we're going to be grouping by store location. And what we're going to be doing is essentially creating a copy of this original data and then applying .shift to it and shifting it up 1 row. And then we're going to take that shifted data frame and attach it to this original data frame, so that we have the previous day's sales for any given day. So as you can see, 4/14/2025 is 1,000 sales volume, and 4/13/2025 is 1,400 sales volume. And as the last step, we're going to calculate the percentage change based on the current day's sales and the previous day's sales for each row in the data frame. So the first step we're going to do is the same step we've been doing all throughout all the examples. We're just going to be using the Excel function to load the Excel data into a pandas data frame so Python can understand it. And we are going to be calling that data frame original data. Then we are going to use the sort values function on that original data frame. And we're going to be sorting by store location and date. So just be sure to enclose those two column names in quotes and put them in list format, so within square brackets and with a comma in between. And then the second parameter we're going to pass into sort values is this ascending parameter, and we're also going to feed a list into this one as well. And the items in this list are going to correlate with the order of the first list we specified. So ascending equals true for the sorting of store location, and ascending equals false, aka descending, for the date column. Also, a little side note about specifying more than one column to sort by. So store location is going to be our primary sort. So it's going to sort everything by store location. And then our secondary sort is going to be date. So each store location is still going to be sorted by store location, and then within that sort, it's going to be sorted by date. Then for the next step, we are going to create our group object by referencing the sorted data frame variable that we created in the previous step, and adding the groupby function with store location as the grouping as the grouping field. So just one grouping field for this demo. Then we're going to apply that .shift function that we talked about onto the group object, and then we're going to specify -1 is as the argument, so that means shift everything up one row, and we're going to store this in the shifted data variable, and notably it gets stored as a data frame, so we're no longer a group object after we apply .shift, meaning Excel can display the values. Then in our next step, since shifted data is basically just a copy of the original data frame, and we're going to be gluing them together side by side, we're going to have column headers in the second data frame that are duplicates to the existing data. So in this step here, we are just changing the column header names of the shifted data frame. And the way we do that is with the .rename function. So we just reference our shifted data frame and rename to it. And then to change column headers, we use the columns parameter. And the way we sort of map the old column names to the new column names is by using what's called a dictionary in Python. And a dictionary is basically just a sequence of key value, what are called key value pairs. And it looks like this up here. So starts with a curly bracket, has what's called the key in quotes if it's a string, and this is going to represent our original column name, and then we have the new column name after the colon. Original column name, colon, new column name. Then we close the curly bracket. And when we supply the columns parameter a variable that represents a dictionary formatted like this, it knows how to appropriately change the column header names. So now that we have our sorted original data frame and the shifted data frame, it's time to concatenate the two together side by side. And to do that, we can use the pd.concat function. PD just stands for pandas, and .concat stands for .concatenate. And then the first argument for the .concat function from pandas is just going to be the two tables you want to concatenate in list form. And because they're variables, you don't need to put them in quotes. Just don't forget the square brackets and the separation by a comma. And when you're concatenating, there's basically two options. You can either glue side by side like we want, and in that case we put axis equals 1, or you can glue the tables one on top of the other, and that's going to be axis equals 0. When we execute this code, we get a data frame that looks like this. So we have the original data right here, and then we have previous day's data right here. So now that we have both sales volume for the current date and the previous date, we can go ahead and calculate the percentage change between those two figures. And to do that, we are going to create a new column in the data frame for all data. And just to refresh your memory, we do that by referencing the data frame we want to add the column to, and then in square bracket specifying the name of the column header for the new column in quotes. And then we set that equal to some sort of code that will tell Python how to populate the cells in that new column of the data frame. So in this case, we are using existing columns in that data frame. So it's just sales volume from the all data table divided by previous day's sales volume from the all data table -1, and that's just going to give us the percent change. So now we have a data frame with the percent change. And as a last step, we are just going to drop this index, which will show up if we were to spill the values right now into Excel, just at this step 7. So in step 8, we are just adding the .reset index with drop equals true parameter to effectively hide the index column when we want to spill the results into Excel. So you basically have two options for that. The first one is you can just, in another Python cell, reference the all data variable that will notably pick up from the most recent Excel cell since we have changed the all data variable several times. Or we could just reference that cell and spill the values with Control Enter like this and get the same result. So 2 ways to do the same thing there. And that concludes this intro video to grouping with pandas in the Python-in-Excel integration. Please let me know if you have any questions in the comments. Other than that, thanks for watching and please subscribe.